All right, so the question that you had asked me about was looking at different salts and determining whether the salt is acidic, neutral, or basic. And the key to this problem is to view it as a double displacement reaction with water. So every single one of these is going to react with water. Oops. So I can imagine plus HOH, plus HOH, plus HOH, plus HOH, plus HOH. And in this, in this double displacement reaction, just like any double displacement reaction, the front of this one is going to go with the back of this one, right? So the cation is going to go with the anion and form a new compound. So in this case, it's going to form NaOH, and the cation of the other one and the sorry. The cation of this one and the anion of this one are going to form a compound as well, giving me HBr. Okay, so it's just a double displacement reaction. Same thing for all the rest of them. Instead of showing you, I'm just going to run through. So this one's going to be NH4OH plus HCl. This one's going to be KOH and H2CO3. This one's going to be LiOH and HF. And this one is going to be KOH and HI. Okay, so again, all I did was I imagined the fact that when I put these salts into solution, they're going to dissociate, and then when they dissociate, they're going to participate in a double displacement reaction where the cation of one goes with the anion of the other, and the cation of that other goes with the anion of that one. And I did that for all of them. So this shows me the two products of the double displacement reaction. Now, to decide whether or not the resulting salt is sorry, acidic, basic, or neutral, I need to compare the products of this double displacement reaction. So for the first one, I have sodium hydroxide and hydrobromic acid. So hydrobromic acid is a strong acid, and sodium hydroxide is a strong base. And when I mix a strong acid and a strong base, the resulting solution is going to be neutral. So sodium bromide is considered a neutral salt. For the next one, I have ammonium hydroxide and hydrochloric acid. So hydrochloric acid is a strong acid. Ammonium hydroxide is a weak base. So in this case, I have a strong acid and a weak base. That means the acid is going to predominate. So this is going to be an acidic salt. K2CO3 is going to give me potassium hydroxide, which is a strong base, and carbonic acid, which is a weak acid. So weak acid and strong base, the base is going to dominate. This is going to be considered a basic salt. Lithium fluoride is going to give me lithium hydroxide, which is a strong base, and hydrofluoric acid, which is a weak acid. So this is going to be basic. And then again, here I have potassium hydroxide, which is a strong base, mixed with hydriodic acid, which is a strong acid, which means that I have a strong acid and a strong base, so this one is going to be neutral. All right, so that is how you look at salts and determine whether or not they are acidic, basic, or neutral.